Hi class, today we're going to look at capital investment analysis, chapter 26. I'm sharing with you a problem that I've downloaded to Excel, which is going to show us how to use capital investment analysis. We're going to be using both the average rate of return method and the net present value method in this particular problem. Capital investments are investments in fixed assets that companies are wanting to make. And what capital investment analysis does is it allows management to evaluate from alternatives in purchasing fixed assets. It allows them to choose which asset is going to be best for the company. And so they've given us some information about this company, which is going to be Ellis Transport and Storage. And they are considering two different types of investment projects. One is going to be a warehouse that they want to invest in. The other is tracking technology. So we're going to be looking at both of these investments and comparing them to see which one would be best for our company. The estimated income from operations and net cash flows from each investment are as follows. Now, these are estimated amounts, and they're thinking that the warehouse is going to bring them income from operations after 5 years for a total of $172,000. In each of the 5 years, they think that this warehouse is going to create some net cash flows, and the net cash flows are listed here in this column. For tracking technology, they've listed the income from operations for the 5 years, and they've also listed cash flow for the 5 years. Each one of these projects is going to require an investment of $368,000. So the warehouse is going to require an investment of $368,000, and the tracking technology is also going to require an investment of $368,000. Straight line depreciation will be used, and there's no residual value expected. The committee has selected a rate of 15% for purposes of net present value analysis. In the first part of this problem, we are not using net present value analysis. In the second part of the problem, we will, and management is thinking that they can get a rate of 15% for purposes of the net present value analysis. Now, what they've given you next is a table that will help you to determine the present value of each one of these investments. So this table is a present value table for a dollar amount at compound interest. This is what we refer to sometimes as a lump sum table. And I'll talk to you about that in just a minute. What we're supposed to do in requirement number 1 is they want you to compute what is called the average rate of return for each investment. Now, when you're computing the average rate of return for each investment, you don't need the present value tables. It's just a mathematical formula that we're going to be using. And they're also telling you that if required, you should round your answer to 1 decimal place. So the formula for average rate of return is this. You're going to find the estimated average annual net income. So we're going to refer back to what they've given us. This is the income from operations. We're going to look at this column for the warehouse, and we're going to look at the income from operations column for tracking technology also. We first are going to find an estimated average annual net income, which means that we're going to take all of these incomes and add them together. In this problem, they've done it for us. They've totaled up the amount of the net income for 5 years as being 172,000. You, however, have to find an average. So we're going to take this 172,000 and divide it by the life of the asset in years. This asset is going to have a life of 5 years. So 172,000 divided by 5 is how we get the estimated average annual net income. And then what you're going to do is you're going to divide that estimated average annual net income by the average investment. And there's some calculations that you have to make for the average investment. And this is the formula for the average investment. We're going to take the initial cost of the asset. We're going to add any residual value if there is any. And this amount will be given to you, the residual value, as well as the initial cost. You're going to combine the two of those together and then divide it by 2. This will give you an average investment. The average investment is divided into the estimated average annual income to get the average rate of return. Now, what we want to do is we want to find the average rate of return on both of our investments. So what I've started with is the estimated average annual net income, the numerator in this problem. And I've put the answer right here for warehouse. But how you get that, again, is you're going to take the total amount of the net income for all 5 periods. You're going to combine it together to get 172,000. Then you're going to divide this by 5 years in the life of the asset. So that will give us, for the warehouse, let me try this again. It's going to give us 172,000 is going to be divided by 5 years. And that's going to give us 34,400. Now, your average investment is going to be your initial cost plus your residual value divided by 2. The initial cost of this investment is going to be 368,000. They told you that there would be no leftover residual value. Residual value is the same thing as scrap value. You might remember that when we were talking about depreciation. So the cost minus the total amount of the accumulated depreciation would be equal to the scrap value or residual value. When you are purchasing a fixed asset, you're going to estimate what you think the amount of that asset will be worth at the end of its depreciable life. And in this case, there was no residual value. So they didn't do that. So it's just 368,000, the initial cost of the investment, divided by 2, which will give you the average investment. The average investment for this problem is, for the warehouse, is 184,000. And if you click on this, you can see up here in the formula bar, they tell you how I got that. So this 368,000 is the initial cost plus 0 for the residual value divided by 2 is your average investment. Once you know the estimated average annual income and the average investment, you can find your average rate of return on your investment. You simply divide the annual net income by the average investment, and that will give you 18.7%. For the tracking technology, we do exactly the same thing. We're using the same formula right here. And to find the estimated average annual net income, what we would do is we would take the total income that they've given us, which is 172,000, and divide it by a 5-year life, because this asset also had a 5-year life. So it gave you the very same thing. It gave you 34,400. The average investment is also the initial cost of the investment, which was 368,000, plus the residual value divided by 2, and that gave you 184,000. If you divide 184,000 into 34,400, it will give you 18.7%. So what we can determine if we just use the average rate of return on the investment is that both the warehouse and the tracking technology have the same amount of the average rate of return. So it really doesn't tell us, how we should, which one is the better choice when we're evaluating the alternatives in purchasing the fixed assets. So what we would have to do in this situation is move to another formula that will help us to evaluate these two assets that we're thinking of purchasing. And so in the second part of this problem, or in part 1B, they want you to compute what is called the net present value for each investment. And they're telling you to use the present value of a dollar table above in your calculations. And if required, use a minus sign to indicate the negative net present value, if there is one. A lot of times there won't be, but in this particular problem, there did end up being a negative net present value. So in Cengage, if it comes up negative, make sure you put a minus sign in front of it. All right. When we're talking about computing net present value, we're always going to be doing this on the cash flows of the assets that we're evaluating. So we're not looking at the income from operations. We're going to look only at the net cash flow for each one of these investments. You can see here that on this first investment for the warehouse, each year is going to give you a different net cash flow that you're estimating over the life of this asset. Because these are different, we have to use what is called the present value of the dollar table. In looking at tracking technology, you can see that there are equal amounts for the net cash flows. In this situation, we could have used the present value of an annuity. What an annuity is a series of equal cash flows that you're expecting off of your investment. But since they told you specifically in the instructions to use the present value of the dollar tables, this is the table value that we're going to be using. And because we are doing the present value of a dollar table, we have to multiply each year's cash flow by the table value amount. Remember in our instructions that the committee selected a rate of 15% for net present value analysis. So we're only going to be looking at this column of numbers to help us in our mathematics for calculating present value. And so what I've done is I've set up a table with each year that we are going to be calculating the present value of each cash flow for each year. So because this these investments had a useful life of 5 years, I set it up for 5 years. And so what you're going to have to do is you're going to have to find the present value of each one of the cash flows for each of those years. So what we're going to do is we're going to take the cash flow amount and multiply it by the table factor. The table factors are these little things right in here for the table. Since they told us that we were using 15%, we're only going to draw from this column here. Because we only have 5 years that we're going to be doing this for, we're only going to be using these first 5 table value amounts. In year 1, the table value amount is 87%. So what you're going to do is you're going to take the cash flow for year 1 for warehouse, which was 135,000. You're going to multiply that by the table value factor for 1 year at 0.87. So 135,000 times 0.87 will give you the present value of that cash flow. Now, what present value means is that $1 today is worth more than $1 tomorrow. So if we're expecting to get the cash flows in the future, what they're doing is they're converting the cash flow that we're going to get of 135,000 to what it would be worth today. We're applying the present value to that. So the present value of 135,000 in year 1 is 117,450. For year 2, we're going to take the, we're going to take the present value of the cash flow, or we're going to find the present value of the cash flow. To do that, we're going to take the cash flow for year 2, which is 125,000. We're going to multiply it by the table value at 15% for year 2, which is 0.756. So 125,000 times 0.756 will give you the present value for year 2 of your warehouse. And for year 3, you're doing this the similar way. We're just using year 3's cash flow. So year 3, it was 110,000 times the table value amount for year 3, which is 0.658. And that will give you the present value for year 3, which is 72,380. For year 4, we're doing the same thing. We're taking the cash flow for year 4, which is 100,000, and we're multiplying it by the table value for year 4, which is 0.572. So that'll give you 57,200 as the present value in year 4 of the cash flows for year 4. So for year 5, the cash flow is 70,000. 70,000 times the table value for 5 years at 15%, which is 0.497, will give you the present value of 34,790. When you combine all the years' cash flows together, the total present value of your investment is 376,320. So right here, simply added all of these together to get the total present value. Then you're going to subtract the initial cost of the investment, which was given at 368,000. Subtract the cost of the investment from the total present value, and what you're left with is the net present value. So what this is telling you is that after the 5 years for the warehouse, we have recovered the cost of the investment with our estimated cash flows, and we have some left over. And so anytime this is positive, this will be a good thing. So this warehouse has a positive net present value, which means that that they think they're going to be bringing in more cash than what the initial cost of the investment will be. So this will probably be a profitable type of asset to invest in. Now we're going to look at the tracking technology, and we're going to do exactly the same thing. Remember, with present value, you always use your cash flows. So for year one, the cash flow was 108,000. We would multiply it by 0.87, which is the table value factor for 15%, 1 year. 0.87 times 108,000 will give you the present value of 108,000 at year one. So 93,690 is found by taking 108,000 and multiplying it by 0.87. To get year two, it just so happens that in this asset, they think they're going to bring in 108,000 in year two. So year two, 108,000 would be multiplied by 0.756 for year two's table value at 15. And that will give you the present value in year two of tracking technology. In year three, we're going to take the 108,000, because in year three, the cash flow is 108,000. We're going to multiply it by the table value for year three at 15% is 0.658. And that's going to give you 71,064. For year four, we're going to take the cash flow at year four, which was 108,000. We're going to multiply it by the table value amount for year four, which is 0.572. And that will give you 61,776. For year five, we're going to take 108,000, which was your cash flow for year five. We're going to multiply that by 0.497, because we're in the fifth year here, and the present value will be 53,676. So you're going to add all of your present value for each of the 5 years together to get your total present value of 362,124. We're going to compare that with what we have, what the asset is going to cost us. It's going to cost us 368,000. So the cash flows that we bring in for tracking technology will not cover the initial investment. So we end up with a negative net present value. If management was comparing the two of these assets, since this one, the tracking, since the warehouse came up with more of net present value, we would choose this one over the tracking technology. So in part two, they have a question for you to fill in the blank. And the warehouse net present value exceeds the warehouse net present value of 8,320 exceeds the selected rate established for discounting the cash flows at 15%, while tracking technology did not. You see, they didn't, they had a negative net present value here. Thus, considering only quantitative factors, that's mathematical factors, we should select the warehouse. But we shouldn't just do it based on mathematics. We should also use other items that might be something that would be important to our operations other than mathematical procedures. So you don't really use these just for evaluation purposes. Mathematics is not the only way to evaluate things. Sometimes we might have to take into consideration what it will do to the morale of the employees or things that are not mathematical before we would make our decision. But if we're basing it straightly on mathematics, the warehouse would be the better decision to invest in than tracking technology. And so that's all I want to talk to you about on this particular problem. We'll see you again next time. Bye-bye.